What's going on, guys? Welcome back to another case study. Today we got a 2022 Mercedes C300 cam crank correlation issue. This one came into the shop. It was running good. This shop just had us come in. They weren't doing any of their own diagnostics on this one, so they wanted us to just come in, check it out, let them know what the issue was with this. So no repairs or anything were done. This car just came in for this check engine light, which is right here, P001685. Position of the intake camshaft bank 1 is implausible relative to the position of the crankshaft. So it looks like there's a timing issue. So first thing I do on a lot of cars that I work on, especially European ones, if I'm going to be using a factory tool and it's going to take a little bit of time to scan the vehicle, get everything set up, I'll just throw my maintainer on it just to keep the battery like fully charged throughout the entire process. There's certain scenarios during testing you may want to take the maintainer off and not have it on, depending, but that's what I had pretty much set up for this one. I noticed right away when I went to start this up, it had a little bit of an extended crank. It started and ran great, just had these 3 codes in here, and the timing one was a stored code, as well as this coolant temp sensor, and then this is just like unrelated. I noticed it had that little bit of a long extended crank, and this code would clear and then it would start up perfect. It wouldn't have an extended crank until the code set again, which it would set. So we verified the issue on this one. Now for Mercedes, this is their factory tool I'm using here, Sentry. This has some data based off of the fault code. So based off of the fault code, a lot of the service info, troubleshooting, etc. is inside a lot of these tools. So this one, you have these like nice data pins here that'll show you, and we see the position of intake camshaft, we are out by like 1.38 degrees. So kind of right there, and that's probably why it ran fine, because it wasn't out much. But this code came back and the testing for this is just addressed that. On all of these, I kind of just do the same thing anyway. I'll hook up my Pico Scope to cam crank, depending which one I'm working on. I only have a 4-channel scope, so if I had something set up where I needed 4 camshafts and then like a crankshaft, I couldn't do all those at a time, so I usually just hook up to whatever side I'm working on. So this happens to be bank 1, so I'm really just focusing on the 2 cam sensors on bank 1 plus the crank sensor. So it'll be intake, exhaust, and then crank. Those are really the only ones that I'm looking at. First thing I did in this one was got all hooked up, did my initial scan. Here's a little snippet of like the pre-scan on this, or the initial quick test it would be called, with the codes. Next thing I did is I went over to Mercedes factory service info, grabbed myself a wiring diagram. Now, if you've never seen these wiring diagrams before, these are a little bit different. They're in black, which looks really cool, and all the components are just numbered. So I have a little legend I like attached here. So basically what we're looking at for this is these are the 3 sensors we're looking at. B70 is the crankshaft, B615 is the intake camshaft hall sensor, and then B616 is the exhaust. So this gives you a nice little, even though these are wrong, these are kind of pointing in the wrong spots. It's like just behind it, but I guess it's just kind of more pointing at the camshaft. But this is the little diagram of where it is, right? And then you could reference that with this diagram here. So we have, this is 2 diagrams. You can see these are numbered on the top, 50, 51, 52. This goes up to 55, and then it's cut, and then it goes up to 105 here to like 122. So I just snipped out a couple little pieces of this diagram for the components that I'm looking at. So we're looking at B616 right here, B615, these would be the cam sensors. And then you could see, I don't know how well you'll see it on here, but we have, this would be like the signal, this would be the ground, and then this goes back to the 5-volt reference, and it'll say it up here on them. So essentially my next step is I need to get to 3 wires out of here. It'd be pin 81 for the crank, and then we'd be looking at pin 58 for the intake cam, and then pin 34 for the exhaust. Now I could show you, I have it here. This would be the entire diagram for like engine control. They're just very long, it's not cut up, so you have to kind of zoom in and zoom out. So I just downloaded this diagram so you could get like a better view of it. So essentially this is a diagram that you'd have. This is their whole diagram, and when you're on there you could click a lot of these and it'll bring you up to different things. I could do another video on this being like interactive with the diagram if any of you guys are interested in these style diagrams. But for now, not the point of this video. Basically just giving you a little bit of a better look at this. So you could see, here we go. We got B616, B615. You could see we have our 2 sensors here. So here's our signal here. We have our ground signal. This is also tied into the ground. And then these would just be like the 5-volt reference for that circuit. Then we can go all the way over here. This would be our last one, B70. Same thing, we have our ground here, right? Our 5-volt reference on the white, and looks like violet. And then just the yellow and white is our signal down here. So this would be the diagram you'd be going through. Again, kind of a pretty impressive looking diagram. So that's what we have there. So here's like another cool thing on Sentry. It will give you right on here, you can just go to installation location and it's like really nice. It'll give you a little legend of what a lot of these are. So you could see like intake cam solenoid here, exhaust cam hall sensor, B616, B615 intake camshaft hall sensor, and then B615, you could just look on here. B615, I'll give you a little point out. B616 is here, and then there'd be another one for this. But so that's what we got there. So basically what I did on this one is this is what I hooked up. This is what I captured here, right? So we're looking at green would be the crankshaft pattern, and I'm looking at intake cam, which would be red on my diagram. So if you look just the way this is, you pretty much just look at the teeth, and we have like two smaller shaped teeth here, two bigger teeth. So I'm really just comparing like where this one lines up right here. It lines like right up on the last tooth before there's this notch. And then on here where it's the known good that I have, same thing. We have our small, and then our two big teeth here. But if you look, we have 1, 2, 3, kind of in that range in between like 2 and 3 there. So this is slightly shifted off. I kind of want to see the exhaust lining up too, just to verify like the diagram's right and everything is good. With this one lining up and this one only being off by that little bit, and then having the data and everything else, this pretty much confirms that the customer is going to have to check the mechanical timing of this vehicle, and that's pretty much going to be it on this one. But pretty interesting. With a couple probes at the ECM, you could back probe a couple connectors and be able to get a really cool diagram like this and compare it to one that you'll take on your own and see if the timing's off or not. This would be the intake, the red, and then the blue would be the exhaust. This is just another area you'd want to line up just to verify that this would be correct. And in some cases it may not. They may have some other issues. I've seen them where like they could both be slightly off by like a teeth or two, and it's only setting the code for the one of them. But that's pretty much what this one ended up being. Again, in this, I kind of give all of this to the customer, let them know everything I did. Obviously, all these signals are great. This is all back probed at the ECM just to verify that the ECM is getting all the proper signals and everything on this. So this one is just going to go back to a mechanical timing issue, something in that area that the shop is going to look at. But the whole electrical side of this is confirmed. Everything is good. So this will be left up to the shop to further investigate the timing. They'll tear it apart and check to see, and then replace whatever components they find to be bad on this one. I'll leave this up here if you want to read through any of this. This is just a little summary that I wrote. All right, with that, guys, hope you enjoyed this. Let me know if there's anything else you guys want to see in these, or if there's any requests that you guys have. If you want me to go through any of these style diagrams, yeah, I'd have no problem going through some of these to show you guys, you know, not that I'm an expert in these diagrams, but I do use them a fair amount. So if you guys would like to go over these and see kind of more how these work, let me know in the comments down below. I could share some of that with you. I'm going to wrap this up here. Nice little short video, just a cool little diag that I had the other week. Nice and simple. I love just some simple things like this. I like using the Pico Scope for this type of work. So this worked out really well. But I will catch you guys on the next one. Like, comment, subscribe down below. Let me know if there's anything else you guys want to see, and I will see you guys on the next one.